Okay. Okay. So before we get started, just this thing that I just passed out here, solving oblique triangles. So I just want to talk about this real quick. And then there's a little issue with the side-side angle triangles. That's the one case where you possibly have 0 triangles solutions, 1 or 2 triangle solutions. So first of all, in section 5.3, we first talked about side angle, angle, and then the angle side angle cases. In that case, there's always exactly 1 triangle solution. At that point, we only had law of sines to find the other sides. And then, since you're already given 2 angles, the third angle can always be found by doing 180 degrees minus the first 2. And then you have that funky side-side angle case. If the given angle is obtuse, there's 2 possibilities. Either there's no triangle solution or there's exactly 1 triangle that will work. If the given angle is acute, there's 3 possibilities. You might have no triangle that works, and I spelled exists wrong there. That's okay, I think everybody knows what that word is. There's possibly exactly only 1 triangle solution, or there might be 2 triangle solutions. And then make sure you know how to use those guidelines I passed out. That's the one comment I want to make. Okay, is about the notation there. Okay. And then lastly, for law of cosines, we did side angle side and side 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 yesterday. You always use law of cosines first to find the third side in a side angle side triangle, or you find a first angle in the side 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 case. And then just be careful, if you're ever going to use law of sines to solve for an angle in either of those 2 possibilities, make sure it is not the largest angle. Right? That avoids having to do that 180 minus trick in the case that your angle is supposed to be obtuse. Okay, so I would just in the side angle side or side side side, if you're ever going to use law of sines, I would just make sure you only do it to find one of the 2 smaller angles. Okay, and then that way you won't have any issues. Now, the book isn't open, but I'll just have to make one up here and just give everybody one to solve. So let's go with a side angle angle. So I guess example, if you like, I guess in an oblique triangle with, and I'll make something up. Let's do a side angle angle first. So what if I tell you alpha is 42 degrees, C equals 7, and the next side would be, if I'm doing side angle, hold on, I'm doing side angle angle. So let me give you, sorry, let's do alpha. Beta is going to be, I don't know, 84 degrees, and side length A is going to be 7. And then we're going to find what's left, which would be gamma, B, and C. So make sure you draw a picture first.
Is that 84?
Yeah, that's 84.
Sorry, there's just reflection on it.
Yep, it's 42, 84, and A is 7. And then I'm just getting the textbook up so I can pull more problems out for us to practice. So I'll just get started on that. Alright, so there's a rough sketch of the picture. And then one thing that's really good to do is make sure you know what kind of a triangle this is. So this is what we would say is a side angle angle triangle. Okay, so this is a side angle angle. Okay, so this is one that you can solve using law of sines. So you're on the thing I just passed out, you're in case 1. Okay, there's always one solution, and you use law of sines to find the other sides. Okay. So, anybody, what did somebody start with? Okay, there's lots of things you could do first.
I started to get B first.
Okay, so you went to obtain B first. Now remember, you could do sine of an angle over any opposite side is sine of any other angle over the opposite side, or you can take the reciprocals. So you can do the length of a side over sine of the angle is the length of any other side over sine of the opposite angle. Okay, so you can use these fractions and you can use their reciprocals as well. So this would be 7 over sine of 42 degrees. And then B would be 7 sine 84 over sine 42. And what did you get for this side?
10.4.
You get 10.4. We'll just round to 1 decimal place. So side length B, or side B has length 10.4. So we know this one. Okay. And then if I want to find side length C, what am I going to need to find first there?
180
Okay. All right, if I wanted to find side length C using law of sines, I would have to know gamma first. Okay. And what's the trick? If you know 2 of the angles, how do you find the third?
180.
Okay, so 180 minus the previous 2. Okay, and somebody calculate that yet?
54.
What is it?
54.
54. Okay, so there's gamma. We have B and we have gamma. Okay, yeah.
You have to know gamma if you want to do sines, either sines and cosines, right?
So you're thinking if I was going to use law of cosines?
Yeah, would you still have to find out what gamma is?
Well, let's see. Would I?
Yeah, because otherwise
Yeah.
you just get C squared.
Yeah, I'll write it down. So I only use law of cosines if I have to, which is in the side angle side or the side 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 case. Otherwise, I always use law of sines because it's easier to solve for. But notice, if you write down the formula for solving for C that you would use for law of cosines, C squared is A plus B squared minus 2AB cosine of the angle opposite C. Right? So if you don't know gamma, there's no way of using that to find C. Okay, so either way, but I'm going to stick with law of cosine or law of sine. So what I can do now is I know gamma is 54, so I can do C over sine 54 is the same again as A over sine of the opposite angle 42 degrees. And again, you can do these in either way. You can do I use the other form, like if I'm trying to find an angle, I would use the reciprocal version, but if I want to find the length of a side, I use this form instead. Okay. So now if you want C, you just multiply both sides by sine 54. And C then would be approximately, what did we get here? Just a 1 decimal place.
8.5.
You get 8.5? And like you said, this was 54 degrees. Let's see if that makes sense. So, yeah, that should make sense because the largest angle of the opposite side would be the longest length, and it is. The next largest angle is gamma, which has the next longest side opposite of it. And then the smallest angle has the smallest side across from it. So that makes sense. Okay. So the side angle ones aren't bad, right? So if you know 2 of the angles in one of the sides, you can always just use law of sines. I think it'd probably be good to do a side-side angle one. Okay, is everybody pretty comfortable with the law of sines where you know there's only one triangle solution for sure? Okay. Now here's one thing I want to point out. So let me do a side-side angle one. They always give you A and C, but I want to do one that's a little bit different. So give me a second, I got to think of some values. So if I want to do a side-side angle, I don't want to necessarily give you this angle right here. I'll do this side, and this side, so we'll know, or I can do beta 2, and I would know A, B, and beta. So hold on a second. Okay. So let me make up another one over here. Okay, so let's solve the oblique triangle with, okay, and then I'm doing what again? Side-side angle. Let's say we have B equals 6, A equals 4, and beta equals, I don't know, 57. Can I be a jerk and change A to C real quick? Yeah, just change your A to a C. So step 1 would just be to just draw a picture of an oblique triangle. Again, there might be an obtuse angle in there somewhere, so my picture might not be an accurate representation. It's just to help me make sense of the other sides and other angles. So again, we don't know alpha and gamma. We know beta is 57 degrees. We know B equals 6, and I know that C equals 4, and we don't know A. Okay, so this is a case of side-side angle. You know 2 consecutive sides and then the next angle. Now, oh, I guess this didn't give me the notation that I wanted. So everybody has that little handout, right, that says what to do to solve side-side angles. Okay. On that sheet, it says that you should always find gamma first. Okay, well, depending on what information they give you, you might not be finding gamma first. You might find alpha first. Okay, so the symbol gamma on your handout, that's arbitrary, right? Whichever angle you solve for first, then you would always, your second possible angle in the second triangle would be 180 degrees minus that angle. So just be careful. Don't always think you're supposed to be doing gamma 1, gamma 2 first, right? It just depends. And maybe after we do this one, I'll do one more to kind of emphasize what I'm trying to get across. Okay, so first of all, what's the only angle you could solve for first here in this triangle? Could I even solve for alpha first?
No.
No, because we don't know the side opposite alpha, right? So the only angle we could solve for first is gamma. So in this case, the notation will agree with the little handout that I gave you. Okay. So find gamma first. I'm going to pass out the quizzes while people get started on this one. I have 2 no names. So if you don't get your quiz back, there's a chance it's probably yours. Claire, Kristen, Drew, Jesse.
Did you put a handout for today also?
Yeah, I gave another one. I don't know if you got it. It's kind of just a breakdown of the different kinds of triangles. So like, we just did a side angle one. So if you know two of the angles, there's always exactly one triangle. You use law of sines to find the other sides. And the third angle, you do 180 minus the other two. And then we're doing side angle now. And there's a handout for that. This is more the guideline for the third case when you use law of cosines. So there's another sheet. I don't know if you got it or not, but.
Okay, thank you.
Jake. Maddie. Chris. Brandon's not here. Brady. Oh, Alexis. Claire. Austin. Ocean. Michelle. Wyatt. Janine. Reed. Celeste. Lisa. Gerardo. Oops. Martin. Isaiah. Ashton. Sam. Sorry. Okay, and then we didn't get a quiz that turn one in. Blake, I'm guessing one of these is yours. Yeah. Okay. And then just write your name on it, and then I'll pass it back to you tomorrow. Thank you, sir. Yeah. Okay. So the first move here again was you find the angle first, one of the two angles, but you can only find gamma first because you know its opposite side. You can't find alpha because we don't know its opposite side. Okay, so what am I going to get? If I want to solve for gamma, I'll do sine gamma over its opposite side, and then we'll set that equal to what?
Sine 57 over 6.
Okay, so we'll do sine beta, which is 57 over the opposite side of length 6. Okay. And then we can multiply the right-hand side by 4. I'm going to skip a step. I'm going to multiply the 4 over here, and then I'm going to take arc sine of both sides. So I'm doing 2 steps at once. And I lied. I said I would never write arc sine, but I just did. But I think it's good that I use both notations, the arc sine or the sine inverse notation.
Never do it again, Chris.
Never do it again?
Never do it again.
Okay. And then what do you get for a gamma, say if you round to
33.99.
33.99. So let's just round that to, we'll just do whole number degrees for this problem. Okay. So you do arc sine. Anybody get anything different, or did we get the same thing for the most part? Okay, Chris, you got the same thing? Okay.
I double checked that.
Okay, so now you know the angle gamma. That's approximately 34 degrees. And then what was maybe a next move?
180 minus.
Okay, so before you found the side A, you just went and found alpha by doing 180 minus the other two. So you subtract the 57 and you subtract the 34. You get what, 89?
89, yeah.
Okay.
But I got 89.01 because I didn't round up.
Okay,
So
but that's fine because we're going to round to the nearest degree, so
well, yeah.
if it was 89.01, that'd still be 89 to the nearest degree. Okay. And then finally, we know there's at least one triangle solution. We just need to find side A. This is now 89. And again, I can use Now, technically at this point, I could use law of cosines if I wanted to. Okay, but again, whenever possible, I use law of sines because I think it's easier to work with. Okay. So now what we'll do is we'll do A over sine alpha, which is 89 degrees, and then I'll use the original information. I don't want to use sine gamma over C because I approximated gamma. Okay, so I'll use 6 over sine 57 degrees. So I'll do B over sine beta, and then A would be 6 sine 84 degrees over sine 57 degrees. And what do you get if you round that to one decimal place?
7.1.
7.1?
Or 7.2, sorry.
You get 7.2. Okay. Now, is that the only solution to this triangle?
Yep.
So how do we know?
Excuse me.
Yeah, what's up?
Why'd you put an 84 down?
Oops. By accident. Sorry. Maybe everybody thought it was perfect. Unfortunately not. It'd be nice, but... Yeah, it was supposed to be 89. I accidentally wrote 4. Maybe it's because 9s and 4s are pretty similar with the stroke. Okay. So, but yeah, thanks for pointing that out. Okay, so some of you said that there's only one triangle solution. Now, again, if you look at the little handout that I made, the gamma isn't really important. You always want to look at the angle you solve for first. Okay, so in this case, we happen to solve for gamma first. So if there is a second triangle, it's going to have a gamma sub 2, an alpha sub 2, and an a sub 2. So since I solved for gamma first in this triangle, the other triangle might have a new gamma, or a gamma sub 2, and it's always 180 degrees minus the first one. And what do you get here? You get, I think this is 146? Okay. And then what's the problem with that? Because if this is another angle in a triangle that has, beta's got to be in both triangles. Okay. Right? So what's the problem? If beta's still in the second solution and that's supposed to be another angle in the second triangle, yeah, you add them together. Notice gamma 2 plus beta was 146 plus 57 degrees, but this is greater than 180 degrees. So there's only one triangle solution. Okay. If the second gamma plus the original alpha is less than 180, there would have been a second triangle solution. And you would have had to find the alpha sub 2 and the a sub 2. Okay.
So do you always compare with the angle it gives you? Like it says when you did the 146 plus 57, you always use it with the one that it gives you?
Yes. So here's back to the original picture. C, B, and beta, if there is two triangles, those would have to be the same in both triangles. Okay, so beta's in both triangles if there's two solutions. Whatever angle you solve for first, the second triangle would have an angle, or gamma 2. It's 180 minus that. And if this angle plus the angle beta, or whatever given angle is, if it's bigger than 180, there's no room for a third angle. So yes, you always compare your second gamma or your second alpha, whichever one you solve for first over here. And if that plus the original angle is bigger than 180, then there's no second triangle. Okay. So what I want to do is just maybe, I don't know, I guess we could do another side-side angle, but maybe let's do a side angle side or a side-side-side, just to do law of cosines once. Okay. Everybody okay on that one? Again, if I just want to say this one more time. If you look at the guidelines I passed out for knowing if there's 0, 1, or 2 triangles, it's not like it says after you find gamma 2. Well, your triangle might be labeled differently. Maybe you find alpha first. Then you'd actually be finding an alpha 2. Okay, so don't get too hung up on the notation. It's whatever angle you solve for first in the first solution, it's always 180 minus that angle for a second solution. Okay, so this time it just happened to agree with the notation on the sheet I handed out. We had to sign for gamma first. But if I had to solve for alpha first, I'd be doing an alpha sub 2 first for the second triangle. Okay, so whatever angle you solve for first, the second triangle, if it exists, is 100, that alpha 2 or gamma 2 or beta 2, it's 180 degrees minus the first. Okay, and then let's see, a side angle side. I'll let everybody work on this for a few minutes. Is it okay if I erase this? Is everybody okay? All right. So this time solve the oblique triangle with the known information. Hold on, let me write this down. So we'll say the given angle is beta, it's 107. We know A has length 9 and C has length 8. So first thing you should do is probably draw a picture and identify what type of a triangle this is. I'll try and draw an oblique one this time. There we go. Right, that looks like it's bigger than 90. So what kind of a triangle would this be this time? Well, yeah, so it's obtuse, but in terms of side angle side or side side side, side side angle. Yeah. Well, we're given an angle between two sides, so this is actually a side angle side. Okay, so you're in case 3. So on that sheet I handed out today, okay, you know an angle and the two sides adjacent to that angle. So you have to use law of cosines first. So I want to give everybody 5 minutes to at least kind of think about this one on their own first before I intervene. Yeah, just round your angles to whole numbers and round your other side to 1 decimal place. That's fine. Okay, so what do you have to find first?
B.
Okay, yep, so if you look at number 3 at what I handed out today, side angle side or side side side, always use law of cosines first to find the third side. So I guess we're looking at the law of cosines. Can someone tell me what the formula is in general, so without plugging in the numbers? If I'm trying to solve for side B, there's a law of cosines that has a b squared on the left. What goes on the right-hand side? So it's the sum of the squares of the other two sides minus twice the product of the length of the other two sides, and then cosine of what angle? Cosine of beta, because that's the angle opposite side length b. And then if I take square root of both sides and plug in all the values, b is going to be the square root of 9 squared plus 8 squared minus 2 times 9 times 8 times cosine of the 107 degree angle. You plug this whole thing in your calculator, you said you got 13.7?
Yeah.
So that's what you should have got for this longest side.
You can check it again.
And double check it. And it works? Okay. You're getting 12.8?
No, it's you. Yep. No, yeah. Yeah. 13.68.
You're getting 13.6. Okay,
Yeah,
yep. And then we're just rounding to 1 decimal, so, okay. Yep. So you should get 13.68 rounded to 13.7. Make sure your calculator is always in what mode when you're doing this stuff?
Decimal.
Yeah, since all the angles are given in degrees in this section, your calculator needs to be in degree mode. Now, remember there's that issue with if you try to use law of sines to find the largest angle, if it's obtuse, law of sines will not give you the right angle. But is there any issues in this problem using law of sines to find the other two angles? No, because the given angle is already obtuse. So I can use law of sines to find these angles, or I can use law of cosines, but again, which one is easier?
Sine.
Yeah, I like law of sines. It's a lot more elegant. There's not as much work you have to do to solve for the angle. Okay, so what'd somebody do? Anybody try using law of cosines, or?
I did.
You did? Okay, you did too, Martin. Okay, so I guess you could. Doesn't really matter. Yeah.
Wouldn't you want to do law of cosines since your length of b is an approximate?
Well, it's going to be approximate either way.
Yeah. Yeah, I think I personally don't care whether you use law of sines or law of cosines. So if your answers are off by just a little bit, to me it doesn't matter as long as you're applying the laws properly and you're getting the same values essentially, then I don't really mind it. We'll do it in both ways just to kind of see if it works out. So, but yeah, I think you're right because let's see. Yeah, either way you have to use 13.7 in either formula. Okay, so if I use law of sines, I could say it doesn't matter which one I find first. Say I want to find gamma. You can do sine gamma over its opposite side of 8 equals sine 107 over its opposite side 13.7. And then the 8 gets moved over to the right, and then you apply sine inverse on both sides. And then what did you get for alpha?
I did.
Sorry, gamma. You might have done alpha first, but...
Yeah, I did alpha first, but I got 34.02 for gamma when
Okay. You got
34.
Yeah.
Okay, so we'll say it's approximately 34 degrees.
Yeah. And then I got 39 for alpha.
And then 39 for alpha, because you can do, alpha would be, okay, so you do the 180
Was it
minus
39?
107 minus 34. And what'd you say you got for it?
I got 39 too. Because my
39?
numbers up. Yeah. Mine's 38.98.
So that was using law of sines to say find this angle gamma. Now let me just use law of cosines just to see. I think rounded to the nearest degree it should give you the same value. Is that right?
It's yeah, if you round it, you get the same.
So let me just make this clear. This problem's done. We found the other two angles and the third side. Okay. So let's just see what would happen if I use law of cosines to solve for gamma. So law of cosines, solve for gamma. Let's see. So what would you have to do there? Well, you'd have to use the law of cosines formula that involves gamma. And I think that one would be c squared equals a squared plus b squared minus 2ab cosine gamma.
If you're solving for gamma but have a, b, and c, you wrote them up. It was arc cosine.
Yeah, I'll write it down because yeah, if I solve for cosine theta first, or sorry, cosine gamma, what you get, cosine gamma is going to end up being a squared plus b squared minus c squared over 2ab.
And then it'd be arc cosine.
Yep. And then gamma would be arc cosine or cosine inverse of a squared plus b squared minus c squared over 2ab.
I just didn't wrote them down on the cosine.
Okay. Yeah, it's probably good practice to write this down and write this down. Just do it as many times as you can to help you remember it. And then this would be cosine inverse now. Grab a marker that's a little more. And the a squared is going to be, what is it, 9 squared plus 13.7 squared.
I thought you were falling for gamma, not alpha. Oh, no, sorry.
It's okay. We got the gamma and c.
No, you just said 9 squared first, and I wrote it.
Yeah, because a squared is the 9 squared, b squared is the 13.7
yeah, no,
squared.
it's fine.
Then you subtract c squared and then divide by 2 times 9 times 13.7. And you plug that into cosine inverse. And then, again, what do you get if you round that to
34. You get 34.
if you round that to the nearest degree, you still get 34 degrees, which is the same thing rounded to the nearest decimal that you got for using law of sines. Okay. But like I said, I think law of sines, if you can use it, it's more elegant. It's easier to solve for. There's more to remember or more work to do to start with law of cosines and solve for gamma. Okay. But the choice is yours. I don't care which way you do it. Okay. I just like to follow the general rule. I only use law of sines if I'm solving for an angle that I know is acute. So I know it's not the biggest angle in the triangle. And then law of sines, we'll always be safe. Okay. All right. Any other questions? I mean, we only have 5 more minutes. Make sure you get some practice. The quiz on Friday. Let's see. Technically, I think the law of cosines homework is due Friday, right?
Yeah.
So I think it would be fair to just say the quiz on Friday will be over 5.2, and then all things oblique triangles. So 5.2, 5.3, 5.4. Tomorrow we're just going to do the next section is just application problems using law of sines and law of cosines. So like navigation problems, you know, what angle do I have to go in to travel this many miles this way? And then the last section in this chapter is about vectors, which is important in physics. So I don't know how many of you have to take a physics class at some point, but that'll certainly be relevant when you get to your physics class. All right, thanks everybody.
Yes, us.